Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Fatal Attraction by Michael Lefkowitz, and this is, I think, a reference to the movie which came out when I was a kid. Starring, I think, Michael Douglas and Glenn Close. I've never actually seen the whole movie. I've seen like snippets of it, but I remember there was not a brouhaha, but it was basically like, oh well, there's some sexual thing or whatever going on. So I never saw it as a kid, and I never actually felt the need to actually see it as an adult either. But maybe that's wrong. Maybe I should go see it sometime. But anyways, here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have magnets, where a digit on the magnet is the sum of all digits in the direction indicated by its tips up to the first larger digit or the grid edge. So, for example, you could have something like this being 8, and then this being 1, 3, and 4, and this would be valid, or you could have 3, 4, and 1, something along those lines, because these 3 digits up to the edge of the grid add up to 8. Now you could have something along the lines of 8, 6, and 2, with that being 9, and that would also be valid, because 8 is the sum of the digits up until a digit that's larger than it, or the first larger digit than it sees. So basically, these two add up to 8, 2, and 6, and that makes 8 is in the digit here, because 8 is smaller than the 9 here. So everything up until the 9 must add up to 8. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we've done magnets before. So one thing is, a magnet cannot be just the single digit that's next to it, right? Because then that would have 2 digits which are the exact same size. It cannot be the sum of that single digit, I should say. It should be the sum of at least 2 digits here, which means in the direction that the magnet is, the next 2 digits are guaranteed to be smaller than the magnets that are next to it. This is guaranteed to be 2, and you can never have more than 3 cells in a row. So you know if it doesn't go to the end of a grid, you have to have a digit 3. You have to have a digit greater than the magnet 3 if it's greater than 3 away. So you can't have 4 digits adding up to a single digit because the minimum of 4 digits is 1, 2, 3, 4. So therefore, we are guaranteed this digit must be higher than this digit here. These 2 digits are smaller than this. This digit is smaller than that. Therefore, all 3 of these are smaller than this cell. And since we have 3 cells here, that means this digit must be greater than that. Well, this digit is equal to the sum of these 2 digits, so this is equal to the sum of these 3, which is basically 2 times that digit. So this has to be, this is at least 3 here, and this is 4, so we have 1, 2 here, or 1, 3 here. And this must be double of that, so this is 6 or 8, which means this is greater than 6 or 8, it must be 7, 8, or 9. So we could do something similar here. These are smaller. These are smaller. These are smaller. We have something similar here. These 3 are smaller, so this must be larger here. We have 2 smaller here, 2 smaller here, 2 smaller here. this has to be 3 or 4 again. And we have 1, 2, or 3 here. This must be 6 or 8. And this has to be 7, 8, or 9. Anytime two magnets face each other, one has to be larger than the other. So we don't know about these. We don't know about, doesn't go all the way here. We don't know. We have a 3, 4, 3, 4 pair, though, in column 5, which eliminates 3. Oh, that means one of these is guaranteed to be 6. The other one has to be 8. Interesting. Because of this 3, 4 pair. So the remaining digits in column 5 have to be 1, 2, 5, 6, 7, 8, and 9. Obviously, this is the sum of 2 digits, at least. So it cannot be 1 or 2. So, if this were not to be bigger than this, the problem is this would be the sum of 4 digits, because 3 and 4 is necessarily smaller than 5 through 9. And that can't be the case. So this must be larger than this digit here. So this is obviously not 1, 2, or 5. Actually, this cannot be 5 because it doesn't have 2 digits adding up to 5 because of the 3, 4 pair in the column. So this has to be 6 here, which means this can't be 6. This can never be 9 because there's no digit that's going to be greater than it. And 9 cannot be here. This can't be 8. So we could have 1, 5 here, 6, and 7. That could work. We could have 2, 5, 7, or 1, 6, 7. Or 2, 7. We could have 1, 7 here and 8 here, and that's 9. So these are the possibilities here. Okay. If this... That's not true. We are guaranteed a 1 here. And we're guaranteed one of these is 3, because if this is 3, this is 1, 2. If this is 4, this is 1, 3. So we're guaranteed 1 here and 3 here. Okay. What does that mean? One of these must be double the other one, right? Because if they're not double of one of them, the problem is this could be... Okay, so if this is smaller than this cell, then this is a sum. Well, not necessarily. You could have 6 here, 3 here, 1, 2. So one of these is double the other one here. So this has to be 3, 4 with 6 or 8 here. So this is 3, 4 with 6 or 8. 3, 4 with 6 or 8 here. And we are guaranteed this has to be the same scenario as this part. Because one of these is double the other. I guess it could be 9 here. Right? No. Anytime you have this as a set, the smaller one of these must be 3 or 4. If it's 3 or 4, that means we're guaranteed 1 is here. And we also know 3 has to be one of these digits, right? Because if it's 4 as a smaller magnet, it must be 1 and 3 adding up, which makes that 8. And 8 plus 1, so even if this is 3, 1, 2, the problem is the other digit has to be double the other one. Either way, we are guaranteed a 3 in one of these cells because of the same reasoning why we have a 3 guaranteed here, right? If this is 3, that obviously you have a 3 in the magnet. If it's 4 in the magnet, it must be 1 and 3 adding up together, and the other side must be 8. So 3 and 1 are here, which eliminates 1 and 3 in the rest of the column. So this can't be 1 or 3, it's 2, which makes this 2 and 1, which makes this a 3, so this is 4. This then must be 6 to be double of 3, 2, and 1, or adding up to 2, 1, and 3. Therefore, this can never be 1, 2 here. It must be 1, 3 as a pair here, which means this can't be 3. This is then 4 and 8. And the reason why it's 4 and 8 is we don't have a 1 to add up with the 4, 1, and 3 to add up to 9. So it must be 8 here. So one of these is guaranteed to have a 9. And it must be the next one after the 4, because otherwise that magnet's going to be too big. So remaining digits in column 3 are 5, 6, 7, 9, with the 9 being right after the magnet. So this cannot be 9 here. 4 is here, which forces this to be 8, which forces this to be 9 here. This is 1, 3 as a pair. This can't be 8 because of 8 in the column. No 6 here because of 6 in the box. No 1 here because of 1 in the box. This is 1, 3 as a pair. Okay. This is 9 here. So these also must be double of another digit, right? Because if they aren't, you would have the sum of 4 digits here. If this were not, and that's not going to be a single digit. So either it's a sum of, this is the sum of these 3, or this is the sum of those 3. Actually, it can't go this way. So if this is less than that, then that's not going to work because that's a sum of 4 digits. So this must be greater than this. So this is double what this is. So this is 6 or 8. It cannot be 8 here. So this is 6, which makes this 1, 2. That doesn't work. That's 1 and 3. Huh. Oh. No. Huh. Okay, we have a problem here then. Huh. How does that work? This is definite. Oh. No, this has to be double of this, right? That's a problem. Huh. Oh. This has to be 9, I think. No, that doesn't work. How does this work then? Because this is 1, 3 as a pair. These two must add up to what that is, because this is going to be much bigger. Because it can't be smaller than this, because then it would... Oh, wait, that's not true. This must... Okay, so that's why that's how that is going to work. This... So if we try to have this be double of this, it can only be 6. And therefore this would be 3, but this would be 1, 2, but that would eliminate all possibilities for that cell. So this cannot be double of this. This must be double of that. So this is 3 or 4, cannot be 4, so this is 3, this is 6, this is 1, 2 as a pair. This has to be greater than that cell. So that's how we work. So then this is 3, this is 1, that works there. This is 6 plus 1, 2, and 3. This has to be greater than 6, it's 7, which makes this 9. 7 and 1 are here. That adds up to 8. We have 9 there. That eliminates 1, 7, 8, 9 in the rest of the column. So this is 2, 5 as a pair, which eliminates 2, 5 in the rest of the column. So this is 6. So that's how this works. This cannot be 6 or 7. This is 6. This is 6. 1 and 2. Can this be no. Can this be 3 digits here? And the answer is no. Because at minimum, it would have to be 1, 4, and 5, which adds up to a single digit. So this must be greater than this. Okay. This is 2, 5 as a pair. Remaining digits in box 8 are 4, 7, 8, 9. And obviously there's no 8 here because of 8 in the column. Remaining digits in row. So this can't be 9 here because it's going to have it has to have a digit that's greater than it. Same with this. Same with this, right? So an 8 can never appear on these magnets. So you could have 3 through 8 on all of these magnets. This can't be 3 because of 3 in the column. It cannot be 4 because 4 would require 1 and 3 to be there. This has to be 4, 5, 7, or 8. Remaining digits of row 9 are 4, 5, 7, 8, 9. No 9 here because of 9 in the column. This digit must be greater than 5, 6, 7, or 8, so this is 6 through 9 there. Okay. This cannot be 3 because of the 1, 3 pair in the box. This is less than 8. This cannot be 8 because of 8 in the row. So this is less than 7. It's 2, 4, 5, 6. This is less than 7. 1, 3, 4, 5, and no 6 because it has to be 2 and 5 at most, adding up to 7 there. This can't be 6 because of 6 in the row. This then cannot be 2. It's not the sum of 2 unique digits. So this is either 4 or 5. So if this is 4, this is 3, and that's 1. If this is 5, it has to be 1, 4, or 2, 3. We don't know. So this is going to be bigger. This is 4 or 5, which means this can't be 4. 5, 6, or 7 means this could only be 1 or 3 here. You can't have 4 because that would force this to be 4, 5, which would be greater than that. Can you have 1? So if this were 3 digits, you cannot have 2 in that set of 3 digits because this is a magnet which is greater than 2 digits. 2 can't be here because 2 in the box. So this is minimum 1, 3, and 4, which adds up to 8, which this can't be. And this digit needs something greater than it, so it must be these 2, and this must be greater. So this is 6 through 9 to be greater than 5, 6, or 7. Okay. Remaining digits of box 2. We have 2, 5, 6. And this can't be 6 because of 6 in the column. No 2 here because of 2 in the row. Remaining digits of row 1, 2, 5, 6, 7. 2, 5, 6, 7, 2, 5, 6, 7. Obviously, 2 cannot be here, and 6 can't be here. Therefore, we have 2 and 6 guaranteed here. Obviously, this can't be 2. In row 1, this has to be 2, 5, 6, 7, with 6 being one of these three. This can't be 6. We have a 2, 5, 6, 7 quadruplet in box 1, which eliminates 2, 5, 6, 7 in the rest of the box. This can't be 5, so this is 9, which means the 8 has to be on the other magnet, so it has to be 4 here. This can't be 4, it's 5. Well, to add up to this digit, it can't be 3 and 5. That would add up to 8, so this must be 1 and 5, adding up to 6, which means this is greater than 6. None of these could be 8. We have a 7, 9 pair here. 9 eliminates 9 in the rest of the column. 7, 9 eliminates 7, 9 in the rest of the box and column. This can't be 5, 6, or 7. Therefore, it's 2, which means this can't be 2 here. This can't be 7 because of the 7, 9 pair in the box. 8 eliminates 8 here. Remaining digits of box 7 are 3, 4, 5, and 6. So 3 is guaranteed to be here. 7 in column 3 has to be one of these two digits, so therefore this can't be 7 here. We have 7, 9 here. Remaining digits in column 2 are 3, 4, and 8. This can't be 3 or 4 because of 1, 3 pair in the box and 4 in the box, so this is 8, which means this can't be 8. This is 3, 4 as a pair, which leaves a 1, 8 pair remaining in box 1. This can't be 1 because of the 1, 2 pair in the row, so this is 8. This is 1. 3 eliminates 3 here, so it's 4 and 3. 6 eliminates 6 here, so that's 5, which makes this 2, which makes that 6. This adds up to 5. This cannot be. This is 1 and 4, or 2 and 3. 6, 5, 1 stops at 7 or 9. 5, 1, 2, 4 stops at 6. 8, 1, 7 stops at 9. 4, 1, 3 stops at 8. 8, 1, 3, 4 stops at 9. Remaining digits of column 1, we have 2, 7, 9. 8, where is 8? Cannot be here and here. Where is 8 in box 8? It has to be here. So that's 8. If it's 2 digits, well, that's going to be interesting. So these are at most 1, 7, 2, 6, or 3, 5. Or it could be 1, 2, 5, but it can't really be 1, 2, 5 because that would eliminate all possibilities for that cell. It could be 1, 3, 4. That is also possible. So those are the possibilities. If this is 8, that would force this to be 9, though. And this has to be less than that digit. So this can't be 9. So this is the sum of 3 digits. Cannot be 1, 2, 5 because of 1, 2, 5. Of the 2, 5 being there, that would eliminate all possibilities there if this is 1, 2, 5. So this must be 1, 3, 4 here. This cannot be 3 because of 3 in the row. That eliminates 4 in the rest of the box because of the 1, 3, 4 triplet. Whereas 4 then in row 9, it has to be here. This is 4. That means this can't be 4. It can't be 3. Where is a 3 in the box? It must be here. This 5, 6 pair eliminates 5, 6 in the rest of the row. There's no 5 or 6 here. It's 2, which makes this 5. There's no 4 here because of the 1, 3, 4 triplet in the row. So this is 7, 9 as a pair. Remaining digits of row 7, we have 2, 6, 7, or 9. And this can't be 6 because of 6 in the column. This has to be less than that, so it cannot be 9. So we have 2 or 7 here. Okay. How do you add up to 8? You have 1 through 7 here. There's no 3 here because of 3 in the column. 2 digits adding up to 8. You could have 1, 7, which would make this 2 and 4. Actually, let's do remaining digits in row 2. We have 4, 5, 7, 8. 1 out of 1, 2, or 4 is definitely here. It cannot be 4 here. If this is 4 here, if this is 4 as a minimum, that would make this 1 and that 2. So 4 and sorry, 4 if 4 were here, that would force this to be 1, that would be 2, and therefore this would be 4 and 5 at minimum, which adds up to 9, which is not greater than that digit there. So this cannot be 4. Therefore, this is guaranteed to have 1 or 2. This is 1 or 2, which eliminates 1 and 2 in the rest of the column. This can't be 1 or 2, it's 4. This obviously can't be 4. There's no 4 here. This is 1 or 3. 1 and 5 add up to at least 6. So this cannot be 5 here. 8 eliminates 8 here. So this is 6 or 7 at most, which means this can't be 7. 5 or 6 eliminates 5 or 6 here. We have this being 1, 4, or 2, 3, and this is 1 or 2, which eliminates 1 and 2 in the rest of the row. So this can't be 1 or 2. It's 7, 9. This cannot be 1, 2, and 1, 2 added together because that only adds up to 3. So this is 5 or 6 here. This is greater than 6 or 7, so it cannot be 6 there. It's 7 or 9. We have a 4, 7, 9 triplet in row 7, which eliminates 4, 7, 9 in the rest of the row. This can't be 4, 7, or 9. It's 2. This can't be 2, 7, or 9. It's 6. We need one of these digits. It's greater than this. We don't know which. One of these is a 9. That's kind of obvious. Remaining digits of row 6. We have 3, 4, 7, 8, 9. No 3 or 8 here because of 3 or 8 in the column. No 9 here because of 9 in the column. This could still be the sum of 3 digits here. This digit is the same as that digit, which is the same as that digit. So mark that as yellow. And it was all yellow. Again, this is 3, which is... So let's look at the magnets we have now. 4 is a sum of 1 and 3, 9 is greater than it. 8 is a sum of 1, 3, 4, 9 is greater than that. 1 and 7 is equal to 8, 9 is greater than that. 1 and 2 is equal to 3, 6 is greater than that. 1, 2, 3 is equal to 6, and 7 is greater than that. 1, 3 adds up to 4, 8 is greater than 4. 1, 3, 4 adds up to 8, which is 9 is greater than. 1, 5 is equal to 6, which 7 or 9 will be greater than. 1, 3, 4 is equal to 8. That goes to the edge of the grid. 1 and 2 add up to 3, and 7 and 9 is greater than 3. 1, 2, 3 add up to 6, which 7, 9 is greater than. Okay. And now we have this magnet. Oh, 6 eliminates 6 here. So this is 5. Which eliminates 5 in the rest of the column. Does that help? Where is 5 in box 5? Cannot be here, cannot be any of these, so 5 has to be here, which leaves this as 479. Remaining digits of column 4 are 2, 3, 4, 7, 9. No 4 here because of 4 in the row. Remaining digits of row 4, 2, 3, 6, 7, 9. 6 and 9 cannot be here. This can't be 2 or 6. Where is the 6 in row 4? Can't be here because of 6 is in the column, so this must be 6 here. So that makes this 1, 2, and 5. 1 eliminates 1 here, so it's 2 and 1. That means 1 can't be here. It's 3 and 1 there. 1 and 2 is never going to add up to this digit, so it must be 1, 2, and this digit here. And cannot be 3. 1, 2, 3 adding up to this digit, so it must be 1, 2, 4. 1, 2, 3 would force this to be 6. We have a 6 in the box. So it must be 1, 2, 4 adding up to 7. This digit is larger than 7, so it's 8 or 9. 8 eliminates 8 here, so this must be 9. That eliminates 9 and 7 here. This is 3. 7 eliminates 7 here, so it's 5, which makes this 6, which makes that 7. That's 5. 6 eliminates 6 here, so it's 5 and 6. This 3 eliminates 3 here. This can't be 3 or 4. 4 eliminates 4 here, so this is 2 and 3 adding up to 5. 3 eliminates 3 here, so it's 1. There's no more 2 here. 3 can't be here because of 3 in the row. Where is the 3 in box 5? It has to be here. 4 eliminates 4 here. 9 eliminates 9 in the rest of the row. This is 2, 7, or 8 here, which eliminates 2, 7, 8 in the rest of the column, so no 7, 8. 5 eliminates 5 here, so it's 4. This can't be 4, 5, or 7. That's 8, which makes this 7, which makes that 9. Therefore, that's 8. This can't be 7 or 8. It's 5. 7 eliminates 7 here, so it's 9, 7, 9. Therefore, there's no 9 here. 9 eliminates 9 here, so it's 7, which makes that 4, which makes that 7, which makes that 4. This can't be 7. That's 9, which makes that 7, which makes that 2. So 2 can't be here. This can't be 2 or 7. It's 9. That makes that 2. This 8, and that a 7. And that's how you solve it. Yeah, a little bit tricky parts here. This was particularly tricky. That was kind of clever. I think I actually saw that at the beginning, noted it in my head, but totally forgot about it. So that was interesting. That's one thing about dangerous about marking these as blue. You overgeneralize there. So be careful about that. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.